So, friends, a big hello to everyone. I'll try to fit into 10 minutes and explain the difference between machines of this type or that type, how the controllers differ, what software they run on, what they can do, how they engrave, what they engrave, how the lenses are changed, and the specifics of galvanometric scanners. Right now, we're using a GPT-58 machine. It's a compact monoblock system of a machine with a built-in galvanometric scanner. The scanner can be changed, but this isn't the top of the line scanner. But let's say what the company decided to put in there, naturally something cheap. It has its quirks, I don't particularly like it, but for the functionality of performing 2D engraving, it's more than sufficient. 2D engraving working in a plane. The controller installed here is a licensed light version, light, and the extended version, which is non-light. This is the difference between a controller that only works with a machine, a pedal, and a rotary axis, which would be the light version naturally, and a controller that works with X and Y coordinate axis. That would be the non-light version, so don't confuse light and non-light here, because in 99% of cases, the light version of the controller is used in all machines. There are two groups of controllers here, gray controllers and white controllers, plus there are many subgroups of them. Therefore, we will only consider two controller options, licensed light and unlicensed light. Other controllers, basically, let's just say, are almost never on sale. So, this machine with a light controller can run under ESCAD version 2.14.16, 2.14.15, specifically licensed ESCAD, and accordingly under the program Lightburn. Yes, the Lightburn program is designed specifically for working with such machines and such controllers. How the engraving is set up and formed? I've already shown all of that, and I've shown how it's all launched too. Right here we have a height map load for 3D engravings, meaning on licensed machines with licensed controllers. Whether it's the light version or the gray version, you can do 3D engraving. There are some nuances. For the licensed ones, I showed that it's done specifically in the Lightburn program. The height map is configured, prepared, and engraved. Lightburn is installed via virtual machine in order to separate the machine's operation. If we install both Lightburn and ESCAD on Windows, then Lightburn will naturally take priority, and ESCAD won't see the machine anymore, and it will launch into versions like, damn, a demo mode? I think, yeah. How do you tell? We have Lightburn running right now, and our equipment isn't showing up here, even though it's fully powered on. And so this specific security device, which will be the USB control here, is exactly what's being used by our virtual machine. So when the virtual machine is turned off, we regain access. On our main Windows OS to work directly with the ESCAD 2.14.16 software. To repeat, 3D engraving on machines with licensed light version controllers. We won't mention light anymore here. I hope it was clear to everyone why light. You can do 3D engraving as well as 2D engraving, or do 2D engraving under the control of software such as ESCAD 2.0, both of which are localized for us. In 2025, in the summer, Lightburn version 2 was released, which allows for 3D engraving with auto rotation. A quick look at the pros and cons. Is the cooling of this machine if we're going to push it at 100% power 24/7. The cooling system has two fans that only this machine will rely on, and accordingly its layout. The source is located at the top. Usually, all sources are at the bottom, where the temperature is naturally lower. So here, you really need to worry about cooling this little machine, or not push it to 100%. The next downside is the repairability of such sources, meaning it's a monoblock system, so you basically send the entire machine for repair if anyone's even going to fix it. Moving on, replacing the controller means breaking the seals. The power supply is located at the bottom accordingly. Then the fans, coolers, everything else is inside this block, so any opening immediately breaks the seals. Next. The Galvo scanner installed here is the only type. You can't fit others. Theoretically, you could use adapters, but that requires a separate power supply. So that's basically an extra headache with installing a separate controller to actually manage this machine. Basically, that's probably its main downside. Also, considering it uses a cheaper Galvo scanner, plus, again, the thread is 55mm with a pitch of 1, so the lenses are specific. You can't just put any lenses you want, say from 20x20mm up to 300 or 400x400, it won't work. You could use adapters, of course, but to just swap lenses whenever you want, well, no. And again, for instance, I have a range of certain lenses, I sell them, and they're in stock, so you have to keep that in mind too. I can afford it, but not everyone will be able to when working with this machine. A pro of this machine, it's very quiet, noiseless, lightweight, easy to transport, 24-volt power. You could even run it off a battery, really. So minimal hassle connection via USB Type-C. It's actually on right now and there's no noise at all. Absolutely. Plus, it does a decent job with 2D engravings, so it's a fast, quiet machine that can also do 3D. But with 3D, there are some quirks specifically because of the Galbo scanner. And also because it emits a very thin, focused beam, getting, say, a smooth line transition will be quite difficult. Again, this machine is the JPT-50M8, specifically MOPA. Moving on, the next version of the machine is the JPT-50LP. Pros, and let's start right off with the fact that this machine can run with either a licensed controller or a generic one. Both will be the light version naturally. You can also install an extended version controller here, not the light version. This is made possible by a block like this, which fits almost anything and is easily repaired. It's modularly repairable, I'll say that right away. You can install any Galvo scanner, any extra attachments, lenses. The thread here is 79 pitch 1. On this Galvo scanner, again, there are cheap Galvo scanners from Galvo Scanner, the 711001, with a 69 pitch 1 thread. Not a very convenient thread, of course, but overall, this scanner performs well. 3D engraving's done using a generic controller, version 2.14.10, with a plugin specifically called Laser Emboss, meaning a plugin that lets you do, say, a height map slice and then engrave it with auto rotation, X settings, polishing, and all that. It's very easy to do here. On these kinds of tags, 3D engraving is done here as well, specifically of St. Nicholas the Wonderworker. On this machine, it can do up to 2 engravings a day without changing the focal length, because we have a focal length offset. So again, this machine's universal because you can install both a licensed and a generic controller here. On the M7 series machines, only a licensed controller is used because we have Q-Pulse control. So there should be a clear understanding. 3D engraving via the software, again, specifically Laser Emboss. Lightburn won't run here on a generic controller, but if we install a licensed controller, then it runs under the Lightburn software. And once more, regarding add-ons like autofocus, autofocus, it's basically all possible to do, but it's extra cost and extra hassle. Whether it's needed or not, who the hell knows? The pros of this machine? Easy to use. The con? No need to set up Q-Pulse control, it's automatic here. The beam is slightly larger, plus there's a halo, which makes the metal polish much better. The processing is much better for 3D engraving, so in that regard, I like it more. That's why the main engraving work is done here. Again, metalwork, Stelmer, 3D stone engraving, 2D engraving, deep engraving, material removal on a 100 lens up to 2 millimeters. So there should be a clear understanding that this machine is more or less universal, if there aren't any super duper fine tasks. So basically, I have 3 different fiber laser machines here, each serving its own purpose and task. And on the 50 watt, I like doing 3D engraving specifically, where it's stable with minimal hassle, specifically under Laser Emboss. Under Lightburn on the JPT-50LP machine, I really don't like doing it. Even though the parameters are fully set up there, the result still differs. More or less every time, especially on titanium. On stainless steel tealer, the transition steps are very visible because we set the laser entry and exit lines very precisely. Laser start TC, laser off, and we get step transitions, so you have to do more passes, more layers. If we do the same on the 50LP series, we get much better 3D engraving quality, whether on stone, metal, or anywhere for 2D engraving. Again, our power unit is at the bottom, so cooling is better with separate extra fans, plus a fan on the source itself, plus a separate controller. Separate power supplies? Accordingly, they all cool each other, so to speak, via the main fans on the chassis. It's easier to clean, blow out, repair, disassemble, and reassemble. So those are probably the pros of this machine. The only downside of this machine would probably be that here, well, what do we have here? There isn't really a downside as such. There's no Q-Pulse control, but then again, it's a JPT-50LP. And now let's move to the machine, then we'll move to the materials, where and how things can be done. The JPT-60M7 machine. Again, visually it's exactly the same machine except for a few things. A dynamic Galvo scanner with a 10mm aperture is installed. That is, our focal length can change dynamically up to 10mm during the engraving process. Whether that's good or bad, I can't say, but it's a specific function for special engravings with height variations. Like that mouse or some pipe or any product that needs to be done with a variation, meaning without changing the z-axis movement quickly in dynamics. There are definitely pros to this. Also, the source we have here is a 60M7. Specifically with Q-Pulse control, there's a certain specificity due to the Q-Pulse setting. Working on thin materials, black contrast saturated colors, color engraving as well, but more or less it's practically no different from the JPT-50LP except for the Q-Pulse control functionality. There's an advantage in this, but there are also downsides, meaning you have to fine tune it more precisely. That same Q pulse control, you'll have to do it yourself manually. There aren't any templates, automatic settings, or automatic adjustment of that same Q pulse. If we want to reset the Q pulse here on the JPT50LP, we just raise the frequency range to 220, 240, 260 kilohertz and higher, higher, higher. This way we can, again, polish metal and do whatever we want. That situation won't work here. Here you specifically need to select the parameters in such a way that in combination with, let's say, Q pulse control, frequency range, speed, power, and density, we would get that same polishing. On the 50 watt LP, all of this happens much more easily. The next, probably pro and con. The pro is working in dynamics, that is, working on 3D engraving. It's possible in such a way that we set the z-axis in a certain position of our focus. During engraving, we have a process of automatic, or let's say dynamic lowering of a z-axis within our aperture distance. But there's also a downside. If you incorrectly calculate the height of your z-axis, specifically the material removal in the z-axis, so if you have, say, a figure 10 millimeters high, but the material is removed twice as fast, then accordingly, your focal distance will stay in place while the material moves down and the process will no longer occur, engraving at the focal distance. So that must definitely be taken into account here, meaning many tests, many checks need to be done, along with many calibrations and settings before starting this equipment. So the equipment ends up working more precisely, but it also requires more data input for the process to happen, well, let's say more or less adequately. This machine runs on SCAD 3.0. It works in 3D engraving with STL files without any various height maps. Height maps aren't used here, but you can, in fact, pull in STL files again to form the object, the volume, on which the engraving will be applied without engraving it. So let's say, hypothetically, you have some object. Let's say it has a modified shape of such a structure. You draw the same 3D model, import it into the program, and place your inscription on this 3D model. And following this 3D model structure, your engraving process takes place with a dynamic focus change in an aperture of 10 millimeters maximum. This, accordingly, is its huge plus as specialized equipment for 3D engraving work. So whether that's good or bad, I don't know. But again, if we're talking about STL files and engraving a 3D model on this machine, then accordingly you need to consider here the factor that the model must be specially prepared. You can't just take any STL from the internet. A model that's printed on 3D printers or was just formed or created by someone and loaded here and start engraving, it'll throw a bunch of errors which will then also be engraved in the process on your workpiece. And you'll have flaws there related to lines and the engraving itself. So the factor must be considered. 50-60 watts of power is more than enough for work, 100 watts. Naturally, they cover more possibilities, but again, this is specialized equipment used for specific goals and tasks. And we consider the factor of lenses again. In most cases, I use a lens with a working field. Here it's 100 by 100, on the 58 it's 100 by 100. The UV laser machine also uses a 100 by 100 lens. Right now it has a 174 by 174 lens. And I have two options for using lenses, a 100 by 100 lens or a 174 by 174 lens. A 300 by 300 lens, which most users get mainly due to inexperience, thinking it's a universal lens that can be used for all occasions. No, unfortunately it doesn't work that way, so a 300 by 300 lens is only if you have a large working field for marking, or for marking the same plastic or some other material that will easily yield to it. When increasing the working field and increasing the focal length, you will always have to add power to get the same result as on a lens. Of a smaller size, a smaller dimension, let's move on to the engraved items. Now let's take a quick look, just visually. I'll tell you which machine can do it, how it can do it, on what software. This item was brought to us from Rostov. The item was made on a mini marker machine, a St. Petersburg company, Laser Center, 2.5D engraving. What it was made on, how it was made, I won't say, but here's the result. The result is like a benchmark. I pay attention to it and accordingly always strive for this result. It's made on 430 stainless steel. It's easily magnetized, so both the steel itself and there's a magnet there. Next is a brass item, 2.5D engraving. It was done under JPT50LP, SCAD 3.0 STL file. Yes, it's possible to do, but there would be flaws here because the model was unprepared. Next, the same JPT50LP, SCAD 3.0 that is, the model was an STL file. It was also done for a very long time, but at the same time, the height difference is more than 2 millimeters here. As for the engraving, the quality is top-notch. 2D engraving in a plane, usually no models, just a regular vector file, depth in engraving, engraving in depth on the same brass. The engraving depth is no more than 2 millimeters. The sampling is of very good quality. It was a similar cliche on aluminum was made back in the day on JPT50LP as CAD 2.0. Moving on. As for the model was also made by us under SCAD 3.0 JPT50LP 3D, that is, a 2.5D model, engraving accordingly. This was also done on brass very quickly. Similar engraving of a 3D model under height maps, JPT5LP. Laser emboss program, engraving on stone. Stone is processed on this machine very well, easily, without any special hassles, without any extra settings, engraving on a 2D tag. That is, actually, the engraving is done from the end, f163 lens, JPT50M, next is 3D engraving. We had two options here, yes, 2D engraving was done on the machine. If I'm not mistaken, JPT50M8 and 3D engraving. Here, because of the coat of arms, we'll have 3D engraving, even 2.5D engraving. Under the laser emboss program on the JPT50LP machine, such engraving is set up very easily. Next is titanium cutting. The titanium was 2 mm thick. Tags, that is. There was 3D engraving plus cutting the edges of these ends. Double pass, very complex, very tedious, about 1,000 passes, ESCAD 3.0, JPT50LP. It took about 10 to 15 hours. So all of this looks pretty cool. It looks really great, but it's a very labor-intensive process. It takes a lot of time. Next is stone processing, like shungite, I think it's called, if I'm not mistaken. The 3D engravings here were done entirely on a JPT50LP using laser emboss. A 2.5D engraving like this on grass was also done with laser emboss on a JPT50LP. The quality's good. After post-processing, 2D engraving, back in the day we did it on either a 60 or a 100, I don't remember which machine now. So deep material removal just on a regular machine without any complications? Just a standard 2D vector engraving. And 2D engraving on a JPT50M machine, the lens was an f163. Or it might have even been an f254 with a 174 by 174 work area. Just a regular 2D engraving. Nothing fancy. This is a piece of petrified wood, or a wood fossil. Moving on, 2.5D engraving, 2.5D engraving, and another 2.5D engraving. These were done on a JPT50LP, controlled by the laser emboss software. The same 2.5D engraving on a JPT50LP using the laser emboss software. This was all done on brass. The engraving depth here is no more than 1 mm or 1.5 mm. The quality of the workmanship is very good. Moving on, these old blanks were made quite a long time ago. Cut in 0.8mm titanium, 100% on a JPT50LP. Because at the time I was doing this, I only had the JPT50LP in my workflow. There were no other machines at all. Well, there were, but they were secondary. They came and went. Here's a double-layered cutting structure for this cool little medallion. Cutting the numbers, the thickness was also 0.8mm. So basically, this is all again for the JPT50LP, but using standard ESCAD 2.0. Now let's move on to the blanks. And let's take a quick look at the blanks, so you don't think I'm only showing you the very best, the most gorgeous, the coolest stuff. No, not at all. I'll show you what I have lying around. Things I felt bad about throwing away. A lot of material was actually just thrown out, to be honest. A whole bunch of blanks were previously made on the JPT50LP that ended up being ruined. For instance, this St. Nicholas the Wonder Worker here got burned. This one turned out okay. It needs polishing, but I think we missed the mark in some spots. Or maybe we hit it. So it might still be usable. I'll have to check, but it probably missed the alignment on the tag itself. And here are the tags that, well, I'd say they're more or less burned, so these tags aren't suitable anymore. Not for any other purposes, but I don't toss them because there's a second side you can practice on. Same situation here, there's a second side I already practiced on, and nothing worked on this one either. These are our, let's say, failures. I've already thrown away most of these items. I gave some away, sent some to people. Everyone who buys consumables from us knows the deal. I occasionally toss in various little extras, stones, tags, whatever. So the 3D engravings that are still decent will also be given away to those who buy from us. Specifically, those who buy consumables regularly. Here's a 3D engraving, but it's very low. Not quality-wise, but the material removal was shallow here. I over-polished this one by mistake. It happens. And this one got a bit burned, but it actually has a good depth of material removal. Maybe it'll even be a working tag, but I don't need it, so I'll actually give it to someone. That's it for the tags. Moving on. Cutting metals, titanium. I have these plates. The metal thickness is VT6, 0.8mm. I'd cut various blanks from it, some products for people. I even cut guitar picks from another piece, and, well, finish them up. Moving on, 3 millimeter thick titanium is cut on, naturally, cutters. I mean, we never cut them on our machines because that would be abusing the equipment. I have these openers too if anyone's interested. I made this interesting tag, made it on a JPT50LP machine. So the tag has 2D engraving done using the ESCAD software. So nothing else was used here. A standard classic version, meaning the inscription plus a deep engraved star on the background with material removal. A tag like this weighs about 7 or 8 grams, no more, although the weight of such a tag in its raw state is approximately 12 grams. Deep 2D engraving is done in ESCAD 2.0 or in Lightburn, and you can also do it basically with the LaserPost plugin. But I don't recommend doing that because I think it's a silly idea. It's burned with f1.63 lenses, good fast material removal up to 2 millimeters deep. So just so you know, if you're engraving on a machine and you need deep engraving specifically, then plan for a 100 by 100 lens. Right, with a small work area, but that's to get the fastest possible material removal. This kind of engraving takes about an hour at most. So the point here isn't about profit, but about the equipment's capabilities. Again, it's a JPT50LP with an f1.63 lens. Deep engraving? Back in the day, I did this engraving on either I can't even remember now, honestly. Let me zoom in on it a bit for you. So it was either a 100 or a 50-watt machine. The removal here was something like, I think, around 5 or 6 millimeters deep. But if we're talking about high detail engraving or removal over large distances, keep in mind that you'll definitely have issues due to the hypotenuse angle deviation. I mean, if you're hitting your workpiece perpendicularly and engraving at a small angle, then everything turns out fine, perfect. As soon as you have a larger angle deviation relative to your blank, the bevel angle will prevent you from getting a good quality or detailed engraving. So keep that in mind too, and definitely don't go for any super mega lenses. Anyway, let's keep digging through our wonderful box. Cutting titanium, pendants, or brass is possible on almost any machine, but it'll just directly depend on the engraving time. So titanium, engraving titanium, of course the JPT50LP works smoother. You can also work a bit smoother on the JPT60M7. I don't really like working on titanium with the JPT50M8. But in theory, if you need something done urgently and fast, you can engrave any piece on it too. Now, I'm not trashing the machine at all, I'm just saying I use it every day, but I don't always use it for certain specific goals or tasks. Okay, just a second. Let's dig around in our box. So cutting and engraving brass, silver and gold, JPT50LP. I wouldn't consider the LP series here because it uses protection in the collimator against reflected beams. And if we're cutting gold or silver, there's a way to protect your machine from, say, burning out or the source failing, thanks to the reflected beam protection. Again, this was cut on brass, I think on the JPT28M8. I've cut things like this on the JPT50M8 and JPT50LP. So is there one specific machine that does it better? No, they basically do it more or less all the same. The JPT50M8 and JPT50LP do it faster than the JPT28M8. The JPT60M7 will basically cut just as fast as the other machines. This is standard 2D engraving using either the cutting mode, the wobble mode, or the engraving mode by creating different contours for this kind of shaping. Same with stainless steel. I don't remember which machine I used for this one. Basically, it's layer by layer material removal, engraving, patinating, and manual polishing on a buffing wheel with felt, titanium washers. Again, we have double engraving here, meaning engraving, material removal, and, consequently, the creation of this beautiful internal relief. It's mostly done on machines like the JPT50LP or JPT60M7. On the JPT50M8, I rarely do it because while you can set the color on the 50M8 series, well, I prefer the random color effect you get when engraving on the JPT50LP machine. With the JPT50LP, you won't get a specific engraving color on stainless steel or titanium, but with, say, fine passes, detailed passes. There's a video about this on my channel, on YouTube. It creates this specific color between blue, brown, and yellow. It's like a gradient rainbow. So in that regard, I like the 50 better. Again, when working in ESCAD. Also, on the 50 with the gray controller, we only work with laser emboss. With the licensed one, we use Lightburn. You can also install ESCAD 3.0 for working with 3D STL files, but that has its own specifics, so you have to choose. Moving on to the last materials, we'll look at stones and then wrap up. Okay, now a quick look at the stones. Again, regarding 3D engraving, everything here was done solely on the JPT50LP using the laser emboss software. It's not just because I love it or anything, but simply because of the convenience, practicality, and speed of working with this machine and this plugin. So the 3D engraving is formed using a height map. For stone, you don't need more than that. It's not metal, so you don't need to do 1500 layers. The depth of removal is controlled by density, speed, power, and frequency, and it directly depends on the stone itself and its structure. Because for 3D stone engraving, you don't need, as I said, to set the density to 1,000th of a millimeter or 5,000ths of a millimeter. So to speak, it's enough to use 3 to 400ths of a millimeter for stone processing at 50 to 60% power and a speed of 3,000 millimeters per second. That's what I call efficient work. There are certain nuances when working with stone. If we set the specs or parameters wrong, for instance, it was just engraving metal, and then we switch to stone, we get a result like this, where the engraving depth increases much faster than we had anticipated, and consequently, we can't keep up with a focal distance. This happens when the focal distance drifts in manual mode, leading to these results. The best stone samples have already been sent out to our subscribers, our clients, and those who purchase various goodies from us. Here's the same story. The fill density was calculated incorrectly, resulting in these deep pits, or material removal that, well, might look cool, but isn't the result we wanted. So I've given you a brief overview of the machines, how to choose one, and what to look for. For most of you, it should be clear now, and any questions should be resolved. Unfortunately, it took me 20 minutes.